Okay, so you have seen imine formation before. So where aldehyde ketone react with primary amine, you get an imine. Now we're going to focus on the reaction with secondary amines. Okay, this is secondary amine now. I got two alkyl groups. Okay, all right, we're going to compare contrast the reaction mechanism. All right, start with imine we did together at the top one. All right, so here's an imine. I just copy and paste. Okay, all right, let's compare contrast. So when the secondary amine react with aldehyde ketone, what's the difference? Well, what's the difference? Which step is different? The last step is different. You all see that? Okay, a little bit typo. That's supposed to be secondary amine, supposed to be this guy. Okay, I just copy and paste from the top. That's why. So change this, add one more methyl group. So use this guy instead of that. Okay. Anyway, so you should be able to see that the mechanism are the same. Okay, except the very last step. All right. Let's start with the top one, the imine formation. What is the purpose of doing depronation? To obtain a neutral compound. The neutral is stable, right? Okay, so if you use a primary amine, you got that extra hydrogen. You got two hydrogen total on the nitrogen. Okay, like two hydrogen total on the nitrogen, like that. All right, one of them got depronated earlier, and we have another one. So if you depronate this hydrogen, the nitrogen will turn to be a neutral. However, in the secondary amine, look at the secondary amine. This secondary amine does not have that luxury of having that extra hydrogen. It doesn't have it, but it's still got a charge. You have to get rid of that charge. It's not stable. Well, no hydrogen right here. We're going to move somewhere. So the beta hydrogen right there. That's the only way you can get rid of the charge. Okay. So instead of depronation, this reaction is called elimination. And you get enamine, not enamine. This is alkene, like alkene, and then amine. We call enamine. Okay, both reaction try to generate a neutral product basically, but the secondary amine doesn't have that extra proton to depronate, so you have to do elimination from the beta hydrogen instead. Okay, all right, that's it. That's the enamine formation. Let's go to Wolff-Kishner reduction.